Hello! In this video, I will be talking about how we build the view projection matrices for our lights. This particular video will cover the general concept for all lights and some specific details about building both the view and projection matrices for spotlights. Additional videos will go into detail for the other light types. Building these matrices is typically one of the harder parts of the shadow mapping technique. Before we start talking about how to build the view and projection matrices, let's review what they are both for. The view matrix represents a viewer's translation and orientation. When building the view matrix, we will need a position and a direction. The projection matrix, on the other hand, defines the region the viewer can see and how much distance changes perspective. When building the projection, the first thing we will need to do is decide if we want a perspective or orthographic projection. When deciding if we want a perspective or orthographic projection, think of the way the light is supposed to be traveling. If all of the light comes from one point in space and fans out in all directions, use a perspective. If all the rays of light are supposed to be parallel, use an orthographic. Keep in mind, an orthographic projection is still a 3D projection. We have a Z component. Things just do not shrink based on distance from the viewer. When building the view matrix, our forward direction, typically the Z-axis, should match the direction of the light. The right and up vectors of the view matrix, typically the X and Y axes, can be calculated using the last 4 steps of the look-at matrix algorithm. Building these view projection matrices will be slightly different for each type of light, due to what information is available to us. Creating these matrices is probably easiest for the spotlight, at least in my opinion, as the spotlight has all of the information we need readily available. For the view matrix, we have both a position and a general direction defined by the light. For the projection, we will use a perspective matrix, as we know the light rays are supposed to originate from one location and fan out in all directions. When building a perspective matrix, we will need to set near and far clip values, as well as an aspect ratio and a field of view. For the near clip value, we're just going to use something that is very close to 0. Any object that is closer to our light than our near clip value will not cast a shadow. We can base the far clip value off of the attenuation values of the light. We don't need the far clip to be any further than the light has an effect. The aspect ratio for the spotlight will just be 1, as we are basically trying to build a frustum around the area of the spotlight, which we could represent as a cone. The last value we will need is the field of view. This can be determined based off of the spotlight's cutoff value, which is actually the cosine of the angle of the range a spotlight hits. In the next video, we will go into more details specific to building these matrices for a directional light.